Hello everyone. Today we are going to discuss construction of scales. So what do you understand or what do you mean by a scale or constructing a scale? Actually, in our day-to-day life or whatever we are manufacturing, when we have to draw, they are of different sizes. Everything cannot be drawn to its own size. For example, any machine component you take, I cannot draw the size of the machine component in its own size. It is not possible. We have to bring down everything onto the drawing sheet, just like your maps that you have seen in your childhood, or even now when you see the Google Maps or anywhere else where you see distances that are shown, or the big buildings, the drawings of the buildings, like that. Anything you see in life, they have to be either sometimes reduced, sometimes increased. Certain objects which are of regular sizes, that can be drawn of its own size. So now the proportion by which we either reduce or enlarge the actual size of an object on a drawing or a map is called as scale. Okay. The scale can be defined as a ratio of reduction or enlargement of an actual object on a map or a drawing. So there are certain things where we may have to enlarge the draw of its size. Sometimes we may have to reduce the original size. Sometimes we may draw it to its full size. So depending on either we are enlarging or reducing or we are drawing it to full size, the scale has its name, right? So these are called enlarging scales, and these are called reducing scale, and some are called as full scale, full size scale or full scale. Clear? Like for example, let us say we want to draw a machine component on a drawing sheet. So a huge machine component that you see in factories, or an automobile part that you see, a wheel, or whatever you want. You can take any of the machine components that you come across in your life, or you can take the civil drawings like a drawing of a building and all. In such cases, the huge drawings, we are reducing them to the size of our drawing sheet or the map that we are drawing, right? Such scales where we are reducing its original dimensions, reducing the dimension by some ratio, because they are called as reducing scales. Examples: machine components. Practically everything that we come across will be of reducing, most of them are reducing size. Machine components, civil drawings, etc. Okay. Similarly, let us say I want to draw a gear wheel in a wristwatch. Let us say a gear of wristwatch. It's a very small gear. Many of you might have seen, or at least you might have known that the one which we keep on our wrist. Right, the gear wheel is very small. So if I have to give it to a manufacturer, I cannot give it of the same size. So in such cases, we are enlarging the dimension, increasing the dimensions and drawing. So they are called as enlarging scales. Okay, and there are many components, a medium-sized components which you come across, which you will draw actual dimension to its actual dimensions. So like this, there are different types of type of scale. You can say enlarging scale, reducing scale, and full scale. Okay. Generally the one which you see outside, the flat rule or the steel rule that you see outside, so they are of standard sizes. They are given by your standard institutions like this. So they are of standard sizes. For non-standard ratios, scales giving either reduced or enlarged lengths, we have to prepare the scale on the drawing sheet. If you remember, you can just go back and check if you have an atlas or something in your home, in your childhood that you have seen. Below every drawing, a scale will be mentioned. That means the length on if they are drawn to the scale, it will be mentioned below every map or every country map that he has given. They will mention the scale, the distance that is shown on the map, and the actual distance. Understand? Okay. This is about the construction. What is scale or the construction of a scale? However, today we are going to discuss construction of three different types of scales that is mentioned in your syllabus. We are not going there. There are 4 or 5 different types, but we are going to focus on 3 different types of scales. One is plane scale, diagonal scale, and third one is vernier scale. These are the 3 scales that we are going to discuss. Okay. So before that, before getting into this construction of the scales, there are certain things necessary for every scale. To construct any scale, you need 3 things. First one, representative factor. Representative factor, written as RF. This is also called as scale factor. I'll explain them what it is. Second, we need to know length of the scale, the length that we are supposed to draw, length of scale. And third, we need to know least count, or the least dimension that we have to, least count of scale, or the dimension, least dimension that I have to measure on the scale. So these 3 things are necessary to construct any scales. So representative factor, length of the scale, and least count of the scale. Most of this will be given in the problem itself, least count of the scale. And these 2 will be given in different ways. They will not directly mention sometimes, particularly the representative factor will not be given directly. They don't say in a problem the representative factor of the scale is so and so. It will be given indirectly. We have to calculate representative factor. Once we get representative factor, we can find the length of scale. We will see these things first, and then we will go to the construction of plane scales, diagonal scales, and vernier scales. So first we will discuss representative factor. We can write as RF equal to length on drawing by actual length. Okay, this is representative factor or scale factor. Both are one and the same. So in the beginning of discussion itself, we discussed the objects are either reduced or increased and then drawn on the drawing sheet. So there is a particular ratio by which we are reducing the object, or we are increasing the length of the dimensions of the objects, right? So that particular ratio, by what ratio we are reducing it, or by what factor, rather in other words, by what factor we are increasing it or by what factor we are reducing it, that factor is called as representative factor. So here you can see length on the drawing by actual length. That means, let us say there is a object of diameter some 10 meters. Let us say, for example, we have a 1 meter diameter object. So definitely I cannot draw 1 meter object, an object with 1 meter diameter on my drawing sheet. So I may reduce it to somewhere around 10 centimeters. So this is the length on the drawing, 10 centimeters, which is representing 1 meter on the ground or actual object, right? So the factor by which we are reducing, or the factor by which we are the factor by which we are reducing or increasing the actual dimension, that is called as representative factor. Okay, so this we can write. Basically scale is linear, so everything, all the dimensions, whatever the way the representative factor is presented, that has to be brought down to linear dimensions. So if representative factor is given in terms of area, so then our representative factor will be root over area on drawing by actual area. If it is given in terms of volume, then our representative factor will be cube root of volume on drawing by actual volume. Basically, all of them has to be, finally it has to come to be linear dimension. That means in terms of length. So when it is given in area, we will take the square root. If the representative factor is mentioned in terms of volume, then we will take the cube root. If it is given directly in terms of length, then we can directly write as length on drawing by actual length. Okay, so this is about representative factor. Apart from just remembering the formula, try to understand what it actually is. So then only in whatever way it is presented in the problem, you will be able to do. So this is by what factor we are reducing or increasing. Okay, simply given as length on drawing by actual length. Right. The second one we want to discuss is the length of the scale. Length of scale. I mean, once we know representative factor, using that representative factor, we can construct a scale of any length. It is not so. There should be the limiting factor, or in other words, the maximum length that we want to construct on the drawing sheet is given by the length of the scale. It is the length with which you are drawing on the drawing sheet. The length that you are drawing on your drawing sheet. On the drawing sheet. The scale length you are drawing on the drawing sheet. So once again, for a given representative factor, we can draw scale of any length. For example, simple example, like all of you, the steel rule or the plastic rule that you are using, it has a representative factor of 1:1. Actually, it is drawn to its actual size, which we discussed in the beginning. So it is drawn to 1:2. So the representative factor is 1:1. Okay. So with the same representative factor 1:1, I can have a scale of 15 centimeters. I can have a scale of 30 centimeters. I can have a scale of 1 meter, so on and so forth. So same representative factor. Here when you are drawing 15 centimeters, same 1:1. Here also 1:1. Here also 1:1. But there should be some limit, or there should be some length that we have to decide. How much length I have to draw for a given representative factor. That is nothing but your length of scale. It is given by length of scale equal to representative factor into maximum length to be measured. Okay, so length of scale equal to representative factor into maximum length to be measured. So this gives the length of scale. So since it is the length that you are drawing on the drawing sheet, obviously the scale you use is either in terms of, or either the dimensions on it are either millimeters or centimeters. So usually whatever the problem is given, in whatever units it is given, we will write length of scale in terms of centimeters or millimeters, or you can write in terms of inches, since you also have inches on your scale. So these three we will use: centimeters, millimeters or inches. So whatever the measurement given, the maximum length will be given in sometimes kilometers, sometimes yards, sometimes foot, sometimes inches, whatever it may be given, you may have to bring it down to centimeters, millimeters or inches. So please remember these two: representative factor and length of scale. Any given problem in scales, first you have to find out RF and then you have to find out length of scale. Okay, sometimes these will be directly given, sometimes you will have to calculate them. Only after that you will be able to construct the scale, right? So to get the length of the scale, we need representative factor. Once we calculate these two, then we can go for the construction. So before you go for construction or learning construction of different types of scales, I would like to give a slide, or I would like to give the units, metric units and imperial units where you come across in your problems. So the conversion of the units, which many of you have already studied in your lower classes. Like for example, 1 centimeter equal to 10 millimeter, or 1 decimeter equal to 10 centimeter, so on and so forth. You can just go through it for a few seconds. or you can make a note of it later on. I will just play the slide once. So here you have metric units. You can see linear measurements are given first. 10 millimeters, 1 centimeter, 10 centimeter, 1 decimeter, so on and so forth. Similarly, here you are given square measurements, like when it comes in terms of area, how to convert. 100 square millimeters is 1 square centimeter, and you can go through this. 100 hectares is 1 square kilometer, which is, you can go through all these things. Similarly, cubic measurements are also given. We can make a note of these things later on. Similarly, you have British units or the imperial units, both square measurements, cubic measurements and linear measurements. Most of me may be knowing linear measurements, like 1 foot is 12 inches, 1 yard is 3 foot, 1 furlong is 220 yards, and 1 mile is 8 furlongs. And you also have further things like 1 furlong is 10 chains, so on and so forth, right? So please make a note of these things. These are very, very important in the sense that they keep coming in the problems, and you should know the conversion to find out this representative factor or the length of the scale. So now we will discuss construction of plane scales, and then followed by diagonal and vernier scales. So first one, plane scales. So in plane scale, you can show, on a plane scale, you can show a unit and its immediate subdivision. Immediate subdivision. For example, you can show centimeters, the immediate subdivision is millimeters. You can show meters, the immediate subdivision is decimeters. You can show decameters, the immediate subdivision is meters. Similarly, you can show foot, the immediate subdivision is inches. So let us say yards, then you have foot. So, or else you can show hundreds of places, hundreds of units. You can have tens, or you can have tens place, or you can have ones. Like for example, here hundreds means, let us say 200. So the immediate subdivision may be 40. Okay. Similarly, tens, let us say I have 40 here. Immediate subdivision may be 5. Something like this. Let us say I have to show 45. So it is 40 plus 5. 240. 200 plus 40. So like this, we can have a unit and the subdivision of its immediate subdivision or subdivision of the unit. So these are the things we can construct or show on a plane scale. So we'll see the construction of a plane scale. We'll take a simple problem and then we'll start constructing a plane scale. Let us take a simple problem here. Yep, here it is. In a map of 36 kilometer distance is shown by a line 45 centimeter long. Calculate RF and construct a plane scale to read kilometers and hectometers for maximum of 12 kilometers. Show a distance of 8.3 kilometer on it. So, as we have already discussed in any problem, first thing we have to do is to find out representative factor. Okay, so here you can see in a map a 36 kilometer distance is shown by a line 45 centimeter long. That means the actual length, actual distance is 36 kilometers. When on the drawing or on the map it is shown by 45 centimeter long, right? So as we have already discussed, RF equal to length on drawing. Here it is given in terms of length, so I am writing in terms of length. Length on drawing by actual length. So this I can write as 45 centimeter by 36 kilometers. As I said, sorry. So RF doesn't have any units, which means the numerator and denominator should be of same units. So here we can see the numerator is 30 in centimeters, given in terms of centimeters, and the denominator is in terms of kilometers. So let us convert that to 45 centimeter by 36 into 10 power 5 centimeters. Okay, now this becomes the RF. So I can write this as further 9 5s and 9 by 4 into 10 power 5. So this is the RF. The next is length of scale. Length of scale equal to RF into maximum length to be measured. So in our problem it is given as 12 kilometers. The maximum length to be measured is 12 kilometers. Here you can see 12 kilometers. Right? So you can write as 5 by 4 into 10 power 5 into 12 kilometers. As I said, we have to convert everything into either centimeters, millimeters or inches. So 12 into, in terms of centimeter, when I convert, it becomes 10 power 5. So here you have 10 power 5, 10 power 5 gets cancelled. 4 ones are 4 threes are. So we have 5 threes are 15 centimeters. So this is the length that you are going to draw. This 15 centimeters, please remember, is representing 12 kilometers. Okay, this you should understand. Once you are drawn, you have to forget about your 15 centimeters. You should focus only on 12 kilometers. Now we will see how to draw the scale. Here we go. Sorry. We are drawing construction of plane scale. This is construction of plane scale. So once again, I am not going to draw them with proper scale, pencil and all. So whatever it is, I am going to do freehand drawing. But when you practice, you should practice with your drafter and scale and pencil and all, proper straight lines and all. Here you may not find so, and divisions and all you should do properly. So here I am going to do freehand drawing. If you can understand the procedure and the construction method, that is fine. So now we will see that. So you can take a line. Now the length of scale is given by 15 centimeters. So you will draw a scale of 15 centimeters. So assume that this is 15 centimeters. Okay. So you can write down. So now, so this is 15 centimeters. Just let you can write down here. This is plane scale that we have constructed or constructing. So its representative factor. Here we have already seen it. Representative factor is 5 by 4 into 10 power 5, and length of scale is 15 centimeters. Representative factor is 5 by 4 into 10 power 5. Length of scale equal to 15 centimeters. So like this we have to mention for every drawing. Now this 15 centimeters is representing 12 kilometers, right? And in our question we are asked to mark 8.3 kilometers on it. Okay, so just for here I am writing this 15 centimeters is representing 12 kilometers, and on that we have to mark 8.3 kilometers, right? We should forget about 15 centimeters. Now we have a 12 kilometer line here. So now I will divide this into 12 equal parts. Let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So you could leave the first division here and then write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. And these are 12 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Once again, these are not equally done, but when you draw on the drawing sheet, there should be 12 equal parts. Please remember, 12 equal parts. Right? Now, one part, since I have this 12 kilometers is divided into 12 equal parts, each part is representing 1 kilometer. Right? Each part is representing 1 kilometer. I will divide this further in the first division which I left in the beginning, that I will divide further into 10 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can write here, the space is very small. 1, 2, 3, 4, 5, 6, 7, 8 and 10. Okay. So this is how we will consider. Now this scale is a plane scale. Construction is done, right? So whatever the distance length of scale we got, that is representing 12 kilometers. So I have divided this, I have constructed a scale of 15 centimeters which is representing 12 kilometers, and then I am dividing this scale into 12 equal parts. Each part is representing 1 kilometer. So now further I have divided this 1 kilometer into 10 equal parts, right? So each part will be 0.1 kilometer or 1 hectare meter, right? So on this scale now I have to mark 8.3. So here you are. Directly go to, that means 8 kilometers and 0.3 kilometers. So go to 8, draw a line, and here this is 0, 1, 2, 3. Right? So this distance is 8.3 kilometers. Okay, this is how we'll construct a plane scale, right? So the first, and all of you, I think all of you know how to divide the line into n number of equal parts. I'll just give a small briefing on that, which I already discussed in the earlier classes. Let us discuss one more problem here. So here I have already done the problem. Actually the recording got deleted, so I'm just going to explain whatever I have already did it. So a 3 centimeter long line represents a length of 4.5 meters. Extend this line to measure up to 30 meters and show on it units of meter and 5 meter. Show the length of 2 meters on this line. So in the very first class of scales, I said we need representative factor, length of scale and the least count. These are the three things necessary to construct a scale. Here you can see the scale has to read up to meter and it has to read 5 meters. So there are 2 units here. So the scale will show meters in multiples of 5, and at the same time it will show the least count on the scale will be 1 meter. So we are going to construct a scale like that, a plane scale. So here the first thing in any problem, given problem, we have to find out the representative factor. So you can see here RF equal to length on the scale by actual length. So a 3 centimeter long line represents a length of 4.5 meters. That means the actual length is 4.5 meters and it is represented by a 3 centimeter long line. So we will write that. So length on the,
here it is not scale, it is length on the drawing. So length on the drawing by actual length. So the length on drawing is 3 centimeter and the actual length is 4.5 meters. So we have to take proper units here. The numerator is in centimeters and denominator is in meters. So let us convert this into centimeters. So we will write it 3 centimeter by 4.5 into 100 centimeters. Right? So we have to be very careful with the units. So RF, representative factor, doesn't have any units, which means both the numerator and denominator has to be in the same units. So and then we got representative factor as 1 by 150. Now second thing is we have to calculate length of scale, the length that we are going to draw on our drawing sheet. So length of scale is given by representative factor into maximum length. We already discussed this at great length in the previous example. So here you can see the representative factor is 1 by 150 and the maximum length to be measured. You can see here, extend this line to measure up to 30 meters. So this is the maximum length that has to be measured. So 1 by 50 into 30 meters. Again, length of scale is the length that we are going to draw on our drawing sheet. So that must be either in centimeters or in inches. So I have converted this into centimeters. So 1 by 150 into 30 into 1 meter is 100 centimeters. So I have written this in 100 centimeters here. I can write this. Okay. So overall we get the length of scale to be 20 centimeters. So now I have constructed a scale with 20 centimeters which is representing 30 meters. Now on the scale we will mark. So first I have divided the scale into 6 parts. So 1, 2, 3, 4, 5, 6. So I have divided the scale into 6 parts. So each part is representing 5 meters. So we can go back to our question and see here. The scale has to show units of meter and 5 meter, and that's what we have done here. So each part is representing 5 meters, and the first part I am divided into again 5 equal parts. So each part will represent 1 meter. So each one here is 1 meter. So we have total 5 meters. So now on this scale I am going to mark 22 meters. Okay. So directly we will go to 20. We don't have 22 direct. So on the main scale, on the main division we will mark 20. So from here to 0 up to here it is 20 meters. Then you have 1 meter plus 1 meter, 22 meters. So you can just go to the numericals 20, and on the subdivisions you can go to 2 and mark it. Now this length is representing 22 meters. So as usual you have to write all these things: representative factor, length of scale, name of the scale, units at the subdivision and units on the main scale. All these things has to be mentioned. So this is how we construct our plane scale. Right, we'll see one more problem. With that we can stop plane scales. So here you can see a cube of 5 centimeter size represents a tank of 1000 meter cube volume. Find RF and construct a scale to measure up to 35 meters and mark a distance of 27 meter on it. So here the first part is describing us about the representative factor. A cube of 5 centimeter size, a cube with each side 5 centimeter, and this cube is representing a tank of 1000 meter cube. So when we have already seen or discussed about representative factor in the beginning, I said it can be given in any form. It can be given in the form of length, it can be given in the form of area, it can be given in the form of volume. So here it is given in form of volume. A cube with 5 centimeter side. So we will calculate the volume of the cube, and that is representing a tank of 1000 meter cube volume. So now first we will find the RF. So here you can see representative factor. When it is given in terms of cube, we will take in terms of volume, we will take the cube root. So cube root of volume on the drawing by actual volume. So volume on drawing is the volume of the cube, and actual volume is 1000 meter cube. So I am here calculating the volume of the cube. So it's 5 centimeter into 5 centimeter into 5 centimeter. We have 125 centimeter cube, and this is representing 1000 meter cube. So this 125 centimeter cube is representing a tank of 1000 meter cube. Okay, so your RF will be cube root of 125 centimeter cube by 1000 meter cube. Again, here we have to be careful with the units. The numerator is in centimeter cube and the denominator is meter cube. So I will convert this meter cube into centimeter cube. So I can write it further, 125 centimeter cube by 1000 into 10 power 6 centimeter cube. Right, 1 meter is 100 centimeters. So meter cube, meter into meter into meter. So I can write it as 100 centimeter into 100 centimeter into 100 centimeters, which makes 10 power 6 centimeters. So when we simplify it, we will get RF as 1 by 200. Okay. So now, so next, as soon as we found RF, we can calculate length of scale. Length of scale is RF into maximum length to be measured. Right. So in our problem here, the maximum length to be measured is 35 meters. So we are taking that 1 by 200 into 35. Again, I have converted that into centimeters. So written as 100 centimeters. 1 meter is 100 centimeters. So the length of scale here is given in terms of meters. So I am converting that into centimeters. Finally, we got 17.5 centimeters. So this is the length I am going to construct. So here again, I have constructed a scale with 17.5 centimeters, and this 17.5 centimeters is representing 35 meters. Okay, so now I have now this scale is representing 35 meters. I can divide it into 5 parts, each part representing 7 meters, or I can divide it into 7 parts, each part representing 5 meters. Either way is correct. So I have chosen to divide this scale into 7 equal parts. So 1, 2, 3, 4, 5, 6, and this is the 7th part. So again, as usual, we will leave the first division, first part, and then we will start writing the numbers. So each part here is representing 5 meters. Please remember that we have divided 35 meters into 7 equal parts. So each part will represent 5 meters. So I have written in multiples of 5, 0, 5, 10, 15, 20, 25 and 30. So this one is another 5, so total becomes 35 meters. So first division, again I am dividing it to subdivisions. So I divided this into 5 equal parts. So then each part will represent 1 meter each. Okay. So remember again, the division of line into number of parts, you can follow any method that you want. Right? You can choose the geometrical method, or if you know the exact division, you can do that by just by marking with your scale. So that I am not discussing, which I already discussed. So you can go through that video. Right, each part is representing now 1 meter. So on this scale, we are supposed to mark 27 meters. Right, we don't have a value 27 directly here. So it is in multiples of 5. So the nearest value to 27 is 25. So I mark 25 on my main scale or the main divisions, and then so 27 minus 25 is 2 meters. That 2 meters I am marking on my subdivisions. So the total length is 27. This total length here I marked represents 27 meters. Right. So this is how we construct a plane scale. This is very, very simple. So we have to find out representative factor, length of scale, and using that length we will construct the scale, and then we will divide into parts as per the given question. So plane scale represents, or on a plane scale we can represent or show a unit and its immediate subdivision. That's all. If you want any more further, if you want further divisions, we may have to go for either vernier scale or the diagonal scale, which we are going to discuss in the next classes. Hope all of you understood this plane scales very well. So please go through the video once again if you are not followed, or you can send, if you have any doubts, you can type them in the comment box below, or you can inquire directly with me. And practice these problems. There are a number of problems given in the various textbooks, both solved and unsolved problems. Please practice them. This is just to get an understanding how scales are constructed and all. So only once again the important points here: finding out representative factor, finding out length of scale. Length of scale should be either in centimeters or in millimeters or in inches, and representative factor, both numerator and denominator should have the same units, because representative factor doesn't have any units. Okay, so hope all of you understood. Thank you. Good luck.